All right, so y'all, this is the second part of 2.4. And so we're going to be using this idea called the Bell distribution. I'm going to walk you through the process how we're going to do these problems, okay? So y'all, let me just zoom in here so I can see this a little bit better. And I'm going to show you y'all how we're going to do this. Step number one, we're going to find our average. Our average is the same thing as our mean, okay? So when I'm reading this problem here, y'all, it says the mean speed of a sample vehicle along a stretch of highway is 66 miles an hour. That is my average, y'all. So my X bar is 66 miles an hour. My second thing, y'all, we're going to find our sample standard deviation. And it says my sample standard deviation is 5 miles an hour. Okay. So, y'all, the first thing I'm going to do is I'm going to label this graph. In the middle right here, y'all, we have our X bar. Well, we said our X bar was 66 miles an hour. Now, what I'm going to do, y'all, is I'm going to add 5 to get this number right here. So if we add 5 to 66, that should be 71. If we add another 5, that should be 76. And if we add another 5, y'all, that should be 81. Now, going to the left, y'all, I'm going to be subtracting 5. So this would be 61. If I subtract 5 again, that's going to be 56. If I subtract 5 again, that's going to be 51. Now, I'm going to look at the question and it says, can we estimate the percent? It's only asking me for a percentage of vehicles whose speeds are between 51 and 81 miles an hour. Well, y'all, that's almost the whole graph. We're looking at everything between here and here, and everything between here and here, y'all, represents 99.7% of the vehicles. That's all we're going to be doing, y'all, with these questions here, okay? Let me scroll down a little further and, oops, and I'm going to do the same thing with the next question here, okay? So look, y'all, step number one, we're going to find our average, which is the same thing as what we call our mean. So my X bar, so it says the mean value of land and buildings is $1,800, okay? Second thing, with a standard deviation of $300. So right here in the middle, y'all, that's going to be 1,800. And then we're going to start adding 300, 2,100, 2,400, 2,700. Okay. If we now start to subtract 300, that's going to be 1,500. We subtract another 3, 1,200, another 3, 900. Okay. Now, I'm going to keep reading here. It says, assume the number of farms is 70. Okay, so look, y'all, my N, that just tells me how many farms we had. We had 70 farms here, okay? Now it says use the empirical rule to estimate the number of farms whose land values are between 1,200 and 24. So look, y'all, here's 1,200, here's 2,400. Everything in this range represents 95%. So 95% as a decimal, y'all, is 0.95. So I'm going to write a 0.95. We're going to multiply that by the number of farms, which was 70. So 0.95 times 70, that's giving me 66.5. But they are asking us to round to the nearest whole number. So, y'all, right here, I would say that's 66 farms. Okay. I'm going to continue to scroll down. There's a next part, and it says, look, if we looked at an additional 26 farms, how many of them would still be between 1,200 and 2,400? It's still 95%, y'all, but 95% of this 26. So again, if I take 0.95 times 26, that's giving me 24.7. Again, they're asking me to round to the nearest whole number. So that's 25 out of the 26 farms. Okay. Let me scroll down a little bit further here in my list, y'all. And let's take a look what we got. It says the mean IQ score of adults is 100. Okay, so first, step number one, my X bar, 100. Number two, my standard deviation is 15. So right here again, y'all, that's 100. If we add 15, 115. If we add another 15, 130. If we add another 15, 145. If we subtract 15, 85, 70, and 55. Okay, now they're asking us, can we find just the percentage of adults between scores of 70 and 130? Between 70 and 130, that looks like that is 95%, and that's all we're trying to find. Okay? I'm going to continue scrolling down a little bit further, y'all, and doing the same exact thing here, okay? So number one, let's find our average. The mean score, that's my average, is 80. Okay. Number two, what is our standard deviation? Our standard deviation is 10. Okay. So just like we did before, y'all, that's 80, that's 90, that's 100, that's 110. If we start to subtract 70, 60, and 50, okay. Now, we want to figure out the percentage. Again, just percentage of scores between 60 and 80. So, excuse me, y'all, all we're looking for is this piece right here. So we're going to take 34% and we're going to add 13.5%, and we're going to come up with 47.5%. Okay. So, y'all, if it's asking me just for a percentage, that's all I'm going to do. Okay. Let me keep moving down my list. Okay. And again, I'm doing the same thing here, y'all. So, look, let's start off again. Step number one, our average X bar 78. Okay. Number two, standard deviation of 4. So look, y'all, that's 78. If we add 4, that's 82. If we add another 4, that's 86. If we add another 4, that's 90. Okay. If we start to subtract 4, that's 74, that's 70, and that's 66. Now, what we're trying to do again, y'all, we're looking for the percentage of scores between 70 and 86. So between 70 and 86, that, y'all, looks like it is 95%. Okay. So as I'm going through these, y'all, I hope they're making sense. Okay. Let me scroll down a little bit further. Okay, let's take a look at what we got here. And it says, in a survey conducted by the National Center for Health Statistics, the sample mean height of women was 64.3. Okay, so look, y'all, step number one, my X bar, 64.3, with a standard deviation S of 2.62. Okay, so let's start to label our graph, y'all. So right here, I'm going to write 64.3, and I'm going to use my calculator, y'all, to find my next number. 64.3 plus 2.62. This is 66.92. Okay. If we add another 2.62, 69.54. And if we add another 2.62, that is 72.16. Okay. And now, y'all, I'm going to start doing that same thing but subtracting. 64.3 minus 2.62, 61.68. Okay. If I subtract 2.62 again, 59.06. And if we subtract another 2.62, 56.54. 54? 44. Okay. All right. Now let's see. What are we trying to find? We're looking for to estimate the percent of the women who are between 59 and 64.3. Okay. Between 59.06, which is right here, and 64.3, which is right here. So again, y'all, I'm going to add those together. 13.5 plus 34%. That is 47.5%, right? Okay. And y'all, I got another problem here in my list. And let's see what it says. The mean value of land and buildings from an acre performs is 1,300 with a standard deviation of 200. Okay, so look, y'all, we got some information already. So here's my bar graph, 1300, let's just write a couple of things. Oops. X bar, 1300. S is 200, so this is 13. It's got to be 15, 1700, 1900. This, if we subtract 2, 1100, 900, 700. Okay, now let's continue to read through the question. The question is asking me right here, are any of the data very unusual? Okay, they're actually asking us for two things. Which ones are unusual, more than 2 standard deviations away from the mean? Okay, so let me explain what I mean by that, y'all. Here is our mean. These numbers are 1 standard deviation away. These numbers are 2 standard deviations away. So we're looking for numbers that are more than 2 standard deviations away. We're looking for numbers that are smaller than 900 or bigger than, what was it, 1700. Okay, so smaller than 900 would be this guy right here. Bigger than 17 would be that one right there. Okay, and then I want to say there was another part. I thought I had it on here, but I'll just tell you what it is. And it says, are any of them going to be very unusual? Okay, so let's do it this way. Let's do the very unusual over here. Sorry. Very unusual. Okay, very unusual, y'all, means more than 3 standard deviations away. So more than 3 standard deviations away, y'all, would be smaller than 1700 or bigger than 900. So let's see. Smaller than 7, bigger than 1900. Well, the only number that's smaller than 700, y'all, is at 628, but there were no numbers that were bigger than 1900, okay? And that's the last part of 2.4.